This problem is mainly about Hugh and the time taken for his journey, given that there is either crossing the lake from P to Q to R, or either he is going to be walking around the perimeter of that circle all the way up to R. The alternative, of course, is that he does a bit of both. So he could be, for instance, rowing his boat from P to Q, and then after that he might walk around to the R. And the problem starts by showing that PQ is 4 cos theta. So what we're going to be looking at is this distance of rowing of the boat. Now it could be any angle. It could be here. It could be at 0 angle. It could be at that theta angle, or it could be at 90 degrees angle. All right, well, we don't know what PQ is, but we do know what PR is, because PR is, the radius is 2, so that means 4 kilometers. And of course we're told that there is a theta angle. To solve this, we're going to need trigonometry, but to use trigonometry we always need to have a right angle triangle. Now if I have a look over here, I could say, okay, well, let's just draw a line down here and we've got a right angle triangle. That's not going to be of any help whatsoever because we now have less information than we had before. So what we're going to do is resort to our good old mathematics through our high school years, and remember that there was a theorem which was called triangle in a semicircle theorem, which meant that if I drew the line from Q to R, then I will get a right angle in here. So if the angle PQR is 90, then we can use trig cosine by knowing those two. And this gives us the answer to our first part, which is in kilometers. Now this is the distance. Now he can row the boat at 3 kilometers per hour because this distance is on the lake. And therefore the time taken for Hugh to row across from P to Q will be, and you can see that that will be dependent on the angle, because at different angles the time will be different. So depending on whether the angle is 0 or 25 or 30 or whatever, the number of hours will change. But this is going to be our time for PQ. So the time for PQ is going to be 4/3 hours. Now we need to find how long the rest of the journey took him from Q to R. And from Q to R, he's no longer rowing the boat, he's now walking. So we need to find the distance QR. This is no longer a straight line, it's a sector. This is a sector of this circle. And to be able to find the sector of this, the circumference or the perimeter of that particular sector, we need to know this angle here. And this angle is going to be 2 theta. This is another example of an angle, which is another theorem, which is angle to center theorem. And since the circumference of a whole circle is 2 pi r, then we can say that our arc QR is therefore 2 theta r, which is 2 theta times, and r is 2, which is 4 theta. That's 4 theta kilometers. Now, since Hugh can do this at 6 kilometers an hour, Then of course the time is going to be distance over velocity, which is going to be 4 theta over 6, which can be now simplified into 2/3 theta. So the total time is 4/3 cos theta plus 2/3 theta, and we remember that has to be greater or equal to 0 or less than or equal to pi on 2, which is 90 degrees. Hugh could have walked all around P to R, or he could have rode across from P to R. At this stage the angle would be 0, or any of the in between. So what we want to find out is at which angle would Hugh take the longest or the shortest time. So we're going to find theta when dt over d theta is 0. And differentiating that equation, we'll get minus 4/3 sine theta plus 2/3. And we're going to make that equal to 0. In my previous video, I showed you exactly how to solve this. So please have a look at the previous video. Do we get the minimum time or the maximum time? We're going to have to draw a sign diagram. But just remember that 0 meant that he was rowing through the lake. Okay, and remember that when pi on 2, that means he walked around. He walked around the lake. Now this will be the sign diagram for dt over d theta. So let's just use any value 0 and insert it into our dt here. So if we say that minus 4 on 3 sine 0 plus 2/3. So if I just look over here and I'll say sine 0 is 0, so this then becomes 2/3, which is a positive number, so I will put positive here. And if I used again sine pi on 2 this time on that side, pi on 2, that means pi on 2 sine pi on 2 is 1. By substituting 1 in here, it'll be minus 4 over 3 plus 2 over 3 will give us a negative answer. We don't need to know what the answer is, we just need to know whether it's positive or negative, so it's negative. In this case, it will mean that this will be our maxima. Okay, so the maximum time occurs when theta is equal to pi on 6. Shortest time will be either when he's rowing through the lake at theta is equal to 0, or when he's walking around the lake at pi on 2. So using t is equal to 4/3 cos theta plus 2 theta on 3, we can substitute theta equals 0 into this equation, and we'll get 4/3 cos 0 plus 2 times 0 over 3. And our answer is going to be 4/3, which is approximately 1.33 hours. If he walks around the lake, then at this time, then we'll substitute pi on 2 cos pi on 2 plus 2/3 pi on 2, which is approximately 1.005 hours. So out of these two, the shortest time will be when Hugh walks around the lake. Okay, make sure you subscribe so you can get solutions to other problems. And if you have particular problems you want me to answer, then please put it down in the comments.